Howdy there, partners. It's time to work on some volume today. We're going to learn something brand new. Today, we're going to not just talk about rectangular prisms and finding volume, but we're going to work on composite rectangular prisms. Prisms that don't look like a normal rectangular prism. So today, if we were to be able to build this, we could take it apart into two separate rectangular prisms. Nice and easy to do when you have cubes in front of you. But we're going to look and see what that looks like on a two-dimensional piece of paper. So when a rectangular prism isn't perfect and regular like this one, and it looks a little bit like this one, we need to be able to take it apart and find the volume of both pieces and then add them together. So come on in and join me to practice finding composite volume. So now we're going to take apart these composite figures to find the volume of composite. Remember, composite means put together. And since we use the Unifix cubes to see what that actually looks like taking apart a composite rectangular prism, now we're going to look at what it looks like on a flat piece of paper, a two-dimensional paper. So y'all know that I am a visual person, so I love to use color to be able to see things in my mind and take things apart. So I'm going to use color today to work through this. Today we're going to do the front page together, and then you're going to practice 4 on your own. Then tomorrow we'll do the same thing. We'll do one page together and we'll practice on our own. Okay? All right, so on this one, I see a composite prism. I see one rectangular prism standing tall, that's figure 2, and then I see one laying flat, this is figure 1. So to help me be able to see the difference between them, I'm going to shade this horizontal prism that's laying flat down so I can see the difference in my mind. It's just easier for me to see if I use color. Okay, so let's take a peek. All right, let's find the prism of this volume of this orange prism that's laying flat first. We remember we need to have the length, the width, and the height for each prism in order to find its volume. The length and the width will tell us the base area, and then we're going to multiply that by the height. Okay, so let's take a look at this one first. Now in the orange, I only see 2 measures. I see the height and I see the length, but I'm missing the width because that's letter A. And remember, in math, when we have an unknown, we can put a variable in its place, which is a letter. So I need to solve this unknown before I can find the volume. If I don't have the width here, this rectangular prism is the same width all the way around. So I'm just going to follow this around. Every one of these is the same width. So if I follow it around my prism, I'll see down here it's labeled with the width of 3. So if this is 3, this has to be 3 as well. So the measure of side A is 3 centimeters. And it's only centimeters because it's just the length. It's one dimension. All right, so let's find the volume of figure 1. I have the length, 9, times the width, 3, times the height, 5. 9 by 3 by 5. I'm going to do 3 by 5 first because I think that'll be easier to multiply. So 3 times 5 is 15, and then I'm going to multiply that by 9. 15 by 9. And I know 9 times 5 is 45, and I also know 9 times 10 is 90. So I'm going to put those together, and that's 135 cubic centimeters for volume. So the volume of figure 1 is 135 cubic centimeters. Now I'm going to find the volume of this tall rectangular prism, figure 2. I need length, width, and height. The length, well, the length is not labeled here, but if I follow it, since it's a rectangle, opposite sides are equal. So if the length's not here, I'm going to go to this opposite side. No, it's not labeled there, so I'm going to go to the opposite side. It is labeled here. So the width is 4. So I have length of 4 times the width of 3 times the height of 9. So volume figure 2 is 4 by 3 by 9. Let's multiply. 4 times 3 is 12. I'm going to do that first, then multiply 12 by 9, basic fact, to get 108. So the volume of figure 2 is 108 cubic centimeters. So the total volume is taking both of those volumes and putting them back together, which makes the composite volume. So I'm going to take 108 cubic centimeters and add it to 135. 13, 4, and 2. So my total volume together is 243 cubic centimeters. There's number 1. All right, let's take a look at the one right below it. This time I see 2 rectangular prisms. Almost looks like a cube. We'll see if it actually is a cube. But I'm going to, again, use color so that I can take apart this composite figure so I can see it. Here I have figure 1 and figure 2. All right. Again, I have a missing measure right here. That's why that variable is there is A. So let's see if we can figure out what the width of this is. This is the width. No label, so we're going to go the opposite side of the rectangle. No label. Keep following that down. No label. Keep following it. No label. Finally, I can see the width that is 8. So that A has to be 8. The measure of side A is 8 centimeters. Okay, so now I have all the measures I need. Let's find the volume of figure 1. Length is 6 times the width. Figured that out was 8 times the height is 7. 6 by 8 by 7. And to be honest with you guys, I really don't mind you using a calculator to solve your multiplication problems because the hardest part of this is finding the correct measurements. So if a calculator helps you and you want to check yourself with a calculator, I'm absolutely fine with that. Right? So here 6 times 8 is 48. Then I have to multiply it by 7. So I have 48 by 7. I'm going to come down here and give myself some more room. 48 by 7. I know 8 times 7 is 56. And I know 40 times 7 is 280. So together, that equals, let me get you some more paper here, 336 cubic centimeters. And again, if you need a calculator to help you with the multiplication, that's absolutely fine because the hardest part is going to be to find the correct measures. Well, we'll keep working on multiplication throughout the year to help you improve that. Okay. Now let's find the volume of figure 2. Here's my figure 2, the orange figure, and I have all 3 of my measures. Perfect. So I have my length, which is 3 from my opposite sides. I have the width, which is 8, and I have the height, which is 3. 3 by 8 by 3. Now I'm definitely going to multiply 3 times 3 first to get 9, and then multiply it by 8 to get 72. So the volume of the small cube is 72 cubic centimeters. Total volume, I need to put those two together. 336 for the larger prism, plus 72 for the smaller prism. And I get a total of 408 cubic centimeters. Remember, you can pause this video anytime you need to catch up and get your writing down in place. Okay? All right, let's do another one together. Let's take a look at this one. Now I have a box or a rectangular prism sitting on top of another rectangular prism. So I'm going to color one of those to separate it in my mind. So I have this orange box, figure 1, sitting on top of the second figure, which is laying horizontally on the bottom. Okay. Now you'll notice I have 2 variables here, A and B, that are missing that I'm going to have to find. So we're going to have to take a peek and see what that may be. So measure of side A. What could this possibly be? This is a cube. So if it's a cube, what does that tell me about the dimensions? If it's a cube, that means that all sides are equal. So here I have 5 centimeters for the width. If this is 5 centimeters for the width, opposite side is also 5 because it's a rectangle. And this opposite side is also 5. So side A is 5 centimeters. Notice every number that I write, I put a label beside it. That's 5 centimeters. This is also a cube, so B is going to be 5 centimeters, equal sides. All right, let's find our volume. If figure 1 is a cube, the volume, length, width, and height are all the same. So I have 5 by 5 by 5. 5 times 5 is 25 times 5. I'm just going to think about 5 quarters right there. 4 quarters make $1, so that would be 100, plus another 25 is 125. So the volume for the first figure is 125 cubic centimeters. Now I wonder, let's estimate before I actually do this. Do we think the volume of this rectangular prism below is going to be higher or lower than 125 cubic centimeters? Think about that one. What do you think? Is it going to be higher or lower? And then let's check and see. I have my length for figure 2 is 15. The width is already labeled, it's 5. And the height is labeled, is 3. So I have 15 by 5 by 3. I'm going to do the 15 by 5 first. So 15 times 5. 5 times 5 is 25. And 5 times 10 is 50. So together that makes 75. And I'm going to multiply that by 3. 75 times 3. 5 times 3 is 15. And then 3 times 7 is, well, 3 times 7 is 21. And that's 70, so it would be 210. Again, feel free to use a calculator with your multiplication to help you check. So if you estimated that the volume of this rectangular prism was larger than the cube, you would be right, because the volume for this one is 225 cubic centimeters. To find the total volume, I just need to add the two volumes together. 125 cubic centimeters plus 225 cubic centimeters. The total volume is 350 cubic centimeters. Excellent. Let's do one last one together, and then I'm going to leave you on your own to explore and see if you can get these on your own. Well, now I'm looking and I see 3 variables that are missing. So this one I'm going to have to search for 3 values. And the one thing I want to make sure you understand is that when there's a missing value, I don't want you to just look at the side and guess what the length is just by what it looks like. You always need mathematical evidence to prove the length of a side by using opposite sides or equivalent sides from somewhere else. So I'm going to show you what I mean. Here's our figure 1 standing nice and tall rectangular prism, and figure 2 is laying sideways. So when this arm is here stretched from side to side, that means from this corner to this corner is 13 centimeters. Now that is a little bit of a problem because I have 2 prisms. I only want this part, and then I want this part for the second prism. So in order to find just this one, I have to think, well, if this is all 13, what would this be? It's got to be smaller than 13. I'm not just going to look at it and say, it looks sort of like 3. I can't really guess that. I have to use mathematical proof. So let's see where we can find information and proof. If this is 13, do I see the value of either this prism from here to here or this one from here to here? Well, from here to here, I'm going to go to the opposite side. Nothing labeled there. Go to the opposite side. That doesn't help me. That's a C. That's a variable. It's unknown. So I'm going to have to use the white. So let's look at this white prism. From here to here, the length of this prism. Not there. Let's go to the opposite side. Not there. Go to the opposite side. Oh, thank goodness. 9 is labeled for the length. So this length is 9 centimeters. So if it's 9 centimeters from here to here, and the whole thing is 13, that leaves over this part, which is 13 minus 9. This would be 4 centimeters. Okay? So if this is 9 centimeters, this has to be 4 because together they make 13. Now I can use this 4 centimeters. Look at the opposite side. This would be 4 centimeters. Look at the opposite side. This would be 4 centimeters. So we just found the value of C. The value of side C is 4 centimeters. All right, well, let's look at A. We need to find A. Here's A. What could the width of this prism be? Well, the width is the same all the way through. So if this is the width, where else do I have the width? Let's find, oh, look at there's a width, and it's already labeled for me. So side A is also 4 centimeters. The last one is side B, this tall prism right here. We need this measure, the height of the orange prism. All right, well, let's look and see what we know to help us solve that. Well, we know this prism right here, when it's laying down, is 5 centimeters. So up until this point, from here to here, that would also be 5 centimeters. I also know that from here to here is labeled for us. That's 5 centimeters. So if the top is 5 and the bottom's 5, then the whole length of the side has to be 10 centimeters together. So the side B is 10 centimeters. So notice I didn't just look at it and say, oh, it looks to be about 8 centimeters, or it looks to be about 9. I went to the opposite side because a rectangle, the opposite sides will always be the same. And I used those opposite pieces to fill in the gaps to figure out how long this was. Right? So now I have a ton of numbers written on these rectangular prisms, and this is where it can get confusing when you're looking for the length, the width, and the height. So we're going to be very careful that we pick the right ones. I'm going to pull a different color out here to see it. So let's just look at figure 1. The first thing I need is the length. If you remember in class, we picked a vertex and found the length, the width, and the height off of that vertex to make sure I had all 3. So the length is 4. I'm going to come down here to write this to give me some more room. Volume is length, 4, times width. I've got to follow my rectangular prism to find it. There it is. Times 4, times the height. And we just figured out that height is 10. 4 times 4 times 10. So 4 by 4 is 16. And then we're going to multiply it by 10 is 160. So the volume of figure 1 is 160 cubic centimeters. Now I'm going to go over to figure 2. For this one, I need the length. I'm not using 13 because we already used these 4 centimeters with this orange prism over here, so I don't want to reuse those cubes. We want to use the new side. So we're going to use the length of 9. The width is still the same, so the width is still 4. And then the height, how tall it is, 5. So when I look at this number sentence, I'm going to do this 4 times 5 first and get 20. Now I can multiply that by 9. 9 times 2 is 18. And add that 0 for being 20, 180. So the volume of figure 2 is 180 cubic units. To find the total volume, I need to put those 2 pieces back together. 160 plus 180 is 340 cubic centimeters. Okay, this just takes training your eyes and training your mind to see what you need to see to find the volume and the length and the width and the shape. If you need to, go back, stop the video, fill in your paper. We've done this one together. So now what I want you to do for today, the last part of today, I want you to flip this paper over and don't worry about the second sheet, that's for tomorrow. These are very similar to what we just did. So I want you to take your time, go back and try to find the composite volume or the total volume for each one of these prisms, and then come back to Canvas and check out the answer key. I'm putting the answer key there because I want you to self-check. As you're practicing these today, you can self-check, and if you have them incorrect, go back and see if you can find your mistake. When you come back to class, you're going to bring your packet in, and I want to see that you've self-checked it and that you've made it right. Okay, so good luck. Turn off your video. Go practice these 4. If you need to use color, and do the best you can. I'll see you in just a little bit.